Okay, sitting at home on question number 9. I want you to read with me. A city's emergency responders determined that 4 traffic accidents occur every hour. I'm going to stop there and I'm going to circle that important information. How do we represent that? Can I represent that as a ratio? Absolutely. So 4 for every hour. I'm going to go ahead, I can also write that. I can also write a ratio as the at the form of a fraction. Okay, I'm going to hold on to that. I'm going to continue reading. Which graph correctly represents the unit rate for this proportional relationship? Go back to unit rate. What is a unit rate? Okay, we discussed this past week that there were many different ways that we can talk about the slope or the constant rate of change, or x over y, or unit rate, constant or proportionality. All of these are the same term, or the same verbiage that we use for the slope. So if you look at all of these relationships, and we're going to move down, we're going to keep on reading this question, for this proportional relationship. Okay, move on down, look at all these choices. Which one, off the bat, can I automatically eliminate? We know that to be proportional, it must go through what? Exactly. Good job, David. I knew you were listening. Okay, which one can I eliminate? A, B, C, D. Yep, the one that crosses right here. Okay, that we can eliminate because it does not go through the origin. Okay, even though it is linear, that means for 1 hour, is 4. 2, 4. It's basically y equals 4. Okay? All right, let's look at the other ones. Choices A, C, and D. We look at the x-axis, which is your time, and we also look at the y, which is the number of accidents. So when we have a graph and we notice that each one goes through the origin, okay, so we satisfied that criteria. And remember that we are looking for the unit rate of 4 to 1, and when I reduce that, that means a slope or a constant rate of change or a constant of proportionality of 4. And so when we're talking about proportional relationships, K is equal to y divided by x. Okay? So I'm going to go to choice A. And I'm going to find where I can find an ordered pair that directly goes where my y and my x meet perfectly. And if you notice, I'm going to find the same amount of distance before I find the next one, right here. Okay, so y divided by x at this ordered pair would be 1. Remember, this makes a natural fraction. Your top number, the line, and then your x. 1 divided by 4. Obviously, that is not our choice. And you see how it could have been a distractor. You see the 4, and you see the 1. Okay, well, no. You have to make sure that your y is always the numerator and your denominator is the x. That is not a choice. Okay, let's look at choice C. If you notice, oh my goodness, it crosses every time we have a change in y and a change in 1. My apologies, a change in y over change in x would be 1 divided by 1. And you know that when it dissects almost vertically perfectly between the x and the y, you're going to have a constant rate of change of 1, especially if it counts 1, 2, 3, 4, and so forth on the y-axis, 1, 2, 3, and so on. That is not our choice. Okay, because remember, we are looking for 4. Obviously, I'm crossing my fingers that it's going to be D. Going up, where do we see it cross? There it is. Keep on going, and I find another one. Remember, you're looking exactly where that y and that x perfectly meet up with our linear equation. So, I look at my y, and it's 4. I have my line, and 1. 4 divided by 1 equals 4. I think I found my answer. Easy schmeezy. All right.